it's Valentine from Simplistic. In this problem, we're going to consider the equation for the decomposition of this compound, SOCl2. And the equation is SOCl2 gives us SO2 plus Cl2. And what's happened is the concentration of the SOCl2 is monitored at a fixed temperature as a function of time during the decomposition reaction. So what you have out here is the time starting from 0 seconds, so the initial time, right up to 1500 seconds. And then for each of the times, you have a concentration of SOCl2 given to you. And as you can see, it starts off at 0.100 molar, and it decreases as the time progresses. So the first thing we need to do is we need to show that the reaction is first order, and then after that, you have to determine the rate constant for the reaction. And the question is, use the graph and the best fitting line to predict the concentration of SO2Cl2 at 1900 seconds. So we have to create a graph first, where on the x-axis we're going to have time, and on the y-axis we're going to have SO2Cl2 concentration, but not quite, because although it seems we need that, but we have to actually make some changes. So before we plot the graph, let's try to understand what is the integrated rate law that we're using out here. So I'm just going to type that out here. So the integrated rate law is going to be ln of, that should be square bracket of A, and this is the concentration at a particular time. So let's call that T at time T. That is equal to negative KT plus ln of the concentration of A at time 0. So we're going to call this, put a 0 after that, okay? And usually these are subscripted, but in Excel, it's hard to make that a subscript. So for the sake of this video, I'm just going to say that's subscripted out here, okay? And what I'm going to do is I'm just going to increase the font size out here so we can keep that in mind. So essentially, we have to draw, plot ln of AT, which is really the changing concentrations of SO2Cl2, okay, versus time T, okay? And the slope of that plot is going to be negative K, okay? And so we're going to have to figure that out. So let's go ahead and put these values in out here. So we first have time in seconds, and we start with 0. You have to type in these values, so, and I know it's a little time consuming, but here's a quick trick. If you just select the first 3 values, because as you can see out here, the time is increasing by 100 seconds right up to 1500. So the pattern is the same, so we can just select that and just drag till we get to 1500. And there you have it, okay? So we have the time in seconds for all of those data points. And then we have to write out the concentration of SO2, Cl2, and this concentration is in molar. Okay, so out here the pattern is not consistent, so we have to just type them all in. So I'm going to type them in, and then I'm going to fast forward the video and show you what I get after that. All right, so now we have all these values in. The next thing we have to do is we have to do ln of the SOCl2 concentration. So I'm going to type that in, because this value is the same as ln AT, okay? So we're going to just go ahead and type ln, and we're going to have Excel do the math for us. So ln open parentheses. So what we do is we do equal to ln open parentheses, and then we just select the cell and close brackets, close parentheses, and then hit it equal to. And at this point in time, we don't have to type the formula in every time, because now a pattern is established. So we're just gonna take our cursor to the bottom right corner of the cell and just double click, and it'll do the calculation for all the cells, as you can see. So once we have all this, now we have everything we need to create a plot. So I'm just going to select this because we have to plot ln SO2Cl2 versus time. So time's on the x-axis, ln of SO2Cl2 is on the y-axis. So we're going to select this. We're going to hit Control and select that. If you're using a Mac, you should hit Command and select that. And then we're going to go to Insert. We're going to go to, where is it? Here we go, Scatter, and we'll select that scatter plot. And as you can see, now we have a very nice scatter plot out here. And what I'm going to do is I'm going to just make this a little bigger, and I'm going to move this scatter plot down here. Okay, maybe I'll just, since we don't need all those data, don't need to look at those, I'm just going to make this a little bigger. All right, so there's our scatter plot, and essentially what you have out here is a straight line. Now, if you compare it with the data, you can see that we have temperature time on the x-axis, and we have ln of SO2Cl2 on the y-axis. All right. So what we want to do is, just to make sure we have everything right, let's go ahead and select this plot, and then we're going to go to Chart Design. We're going to go to Quick Layout out here, and we're going to choose the first one. That way we have the axis titles. I'm going to select the y-axis title, and I'm going to type in ln of SO2Cl2. Okay, so we know what that is. And just delete that rest of it. And then out here, I'm going to type in time in seconds. All right. So now we know what's on the axes. I'm going to delete the title. We don't need that. I'm going to just delete that as well. Okay, now the next thing we want to do is we want to select the points out here. Okay, so select all these points, and we are going to click on Add Chart Element, and then we're going to click on Trend Line. Now, if you're using a Windows, you can actually find all these options right here itself. Okay, and so in some cases, you'll find a plus sign up here out here, and you can access it from the plus sign, the trend line. So we're going to create a trend line out here. So just select, make sure you select any of the points out here. Sometimes it will select one, sometimes it will select more than one. We go to trend line, and we're going to go to linear. Okay, and when we do linear, you see it connects all the lines together, or all the dots together with a straight line. Now we want the equation of the straight line. Okay, so to find the equation of the straight line, again, we're going to go to trend line, and we're going to go to more trend line options. And on the right hand side, what we have is we're going to select set display equation on chart, and that's it. So now we have this equation. Oops, okay, here we go. There's the equation, and I'm gonna make this equation a little it wasn't getting as big as I thought, but anyway, so here's the equation. Okay, so in this equation, y is equal to ln of SO2Cl2, x is equal to t, and then negative 0.0003 is equal to negative k. Okay, so k, so for the problem, it says, first of all, we showed that the reaction is first order and determine the rate first order. Why is it first order? I'm sorry, I'm jumping ahead. So the reason it's first order is because if the plot that we created, actually, if all the points are a straight line, okay, if they're in a straight line, that means they follow this integrated rate law. Therefore, it is definitely first order. And this integrated rate law is that of a first order reaction. All right, so now if this was a second order, then it would be a little different, but right now they're asking us for first order, so we use the equation for a first order and just prove it by making it a straight line. All right, the next thing we want to do is we want to find the rate constant for the reaction. So the rate constant, as you can see, if you look at the equation of the straight line, it's 0.0003. That is k. Okay, so rate constant k is equal to 0.0003. And for the first order, that is second inverse. So I'm just going to put per second. All right. So that's the unit of rate constant, and that is the value. All right. Then the next question is use the graph and the best fitting line to predict the concentration of SO2Cl2 at 1900 seconds. As you can see from the data given out here, we only have data till 1500. So we have to truly make a prediction. So to make this prediction, we're going to use this equation that was generated from the straight line. Okay, so we're going to write, now remember, we're trying to predict the concentration of SO2Cl2. This concentration of SO2Cl2 is actually equal to Y. The ln of that concentration is equal to Y. So we're just going to do ln of SO2Cl2, and then in the next line we're going to do is equal to minus, and then we're going to type out the value of K, that's 0.0003, and that's times. So times, what is X? X is the time, right? So the time in this case is 1900 seconds. So we're going to do 1900. And I think we have to do a little multiplication symbol out here. There we go, 1900. And then plus, and then ln of A naught out here is actually this value, negative 2.3026. So we're going to write that plus negative 2.3026. All right, and now we hit enter. And when we hit enter, that is the log of the concentration of SO2Cl2 at 1900 seconds. Okay, so now to find the concentration, so we're going to do SO2Cl2, the concentration at 1900 seconds, that is going to be equal to the anti-log of that, right? So I'm going to do that in my calculator, and that's the way you want to do it in your calculator is you want to essentially type in that number, so 2.8726, and then you want to hit the plus minus sign, that way it changes it to the negative, and then you want to hit the e to the power x button. Okay, so when we do that, we get 0.05655. all right, and this is the answer. This is the concentration. Now let's make sure we have correct significant figures out here. Say in all these cases they're actually expressing the answer, the values with 3 significant figures. So out here we want to round the last one to 0.566, and that is the concentration is in molar. All right, so there you have it. That's how you solve this type of a problem. I hope that made sense. Thank you for watching.